Last section of this chapter or unit, whatever, is product and quotient rule. So how you take the derivative of a product and how you take the derivative of a quotient. So the derivative of a product, if you have a product of two functions, is the derivative of the first, leave the second, plus you leave the first and then take the derivative of the second. So it's like you kind of travel the derivative down, like you're almost distributing the derivative as you go. You can actually extend this to three functions if you want. So if you have three functions multiplied, you take the derivative of the first, leave the other two, then the middle one, and then the last one. So you just kind of travel the derivative to each function, adding in between. All right, so the challenge sometimes is figuring out when it's a product. If you have, this one, fairly obvious, it's a product. If you have two things that are multiplied that both have x's in them, it's a product. Okay, so x e to the x is the one that often kind of gets overlooked for product rule, but it is a product. You've got two x's and they're multiplied, so that's a product. We can't simplify this like we did one before that was x square root of x. You could actually simplify that to avoid using product rule. You don't have to use product rule on that. But on this, you do. There's no way to simplify it. So, derivative of this, we're going to take the derivative. This is our, I should not call this f, that might be helpful, but this is our f and this is our g. So when we look at the formula, we take the derivative of f first, of the first one first. So derivative of x is 1. We leave the e to the x, so this is our f prime g. Then we do plus, we leave f, and then we take it times g prime. And this is the confusing thing with e to the x. The derivative of e to the x is e to the x. So this is our derivative. Now, could you simplify that? Yes. You could factor out an e to the x and kind of write it in a different way. But do you need to? No. All right, leave it this way. If for some reason you had to do this for a multiple choice type thing, maybe on your quiz, you might want to simplify it to see if you can get it to match one of the answer choices. But otherwise, you don't need to simplify. On this try problem, yes, you could FOIL this out. So you could avoid using quotient rule if you wanted to. You can multiply it out. But I want you to, or not quotient rule, product rule. I want you to use product rule. All right, let's take a look at this example. So f of t equals the square root of t times a plus bt. This is another one where we could avoid quotient rule if we, or quotient rule, where we could avoid product rule if we wanted to by distributing. I'm going to leave it this way. The reason why I wanted to do this one was because of the a and the b. So we have three variables in this function, but this is f of t. All right, this is where that notation dy dx, in this case we'd say df of t dt, is important because this notation is telling us that our variable that we're taking the derivative of is t. Everything else we treat as a constant. All right, so a and b we can treat like a is 3 and b is 2 if we wanted to. They're just numbers. So we kind of ignore them as far as taking the derivative goes. So remember, the square root is t to the 1/2. This is our f, this is our g. So product rule is f prime, so we're going to bring down the power on the t, subtract 1. There's my f prime. Then we leave the g, don't take the derivative of g. Then we do plus f, and you can write it as square root of t or t to the 1/2, whichever. So this is my g. So there's f, g prime. So g prime, a is a constant. The derivative of that is 0. bt, t is our variable, derivative of that is 1, and then b is a coefficient. So this is going to be b, is g prime. All right, this last one is a common type of problem on like AP exam type things with this. They want to know, do you get the concept of the rule? So they don't really care. I mean, there are problems like these on there as well, where you have to take the derivative and show that you know how to do it. But this is, do you understand the concept of the product rule? So f of x is x squared times g of x. And then they give you some information about g, and they ask you to find f prime of 4. Before we can find f prime of 4, we've got to find f prime. All right, so the derivative of this, we've got two x's, and they're multiplied. So we have to use product rule. All right, so this is my f. This is my g, ironically named g. Derivative of f is first. F prime is 2x. leave the g alone. So this is my g. Plus f, which is x squared, and then derivative of g. Well, we don't know what g is, so we're just going to write g prime. All right, that's the derivative of g. So then we want to find f prime of 4, so we plug 4 into everything. We get 2 times 4, g of 4, plus 4 squared, g prime of 4. Plug in our numbers. 2 times 4 is 8. G of 4 is 2. That's where this comes in. Plus 4 squared is 16. G prime of 4 is 3. And that is 16 plus 48, which is 64. Okay. They can also ask you to do this sort of thing from a graph. Like they could give you a graph of G. All right. So then you could find G of 4 from the graph. And G prime of 4, well, how the heck do you find that? That's the slope. So presumably the graph would be straight lines, and you could find the slope on there. I usually do an example with the graph, but I couldn't find a graph that worked, and I can't draw on here very well. But we can do one in class if you want. In fact, I think there might be one on the worksheet that you have. Quotient rule. So quotient rule, a derivative of a quotient, we do f over g, is g times f prime minus f times g prime. Now you might, over g squared. You might take a look at this and be like, oh, that's the same as this, they're just in a different order. It's g f prime instead of f g prime, or instead of f prime g. It doesn't matter the order it's multiplied. The main thing is you need to have this term first. All right, this is basically product rule, but with a minus. Okay, so since it's subtracting, the order matters. Before I realized that it was product rule with a minus, my calculus teacher used high, actually he didn't use this, but it's a little inappropriate what he did use, at least this day and age. He did high over low, so the derivative of high over low. So he said it was low d high, the d stands for derivative, low derivative of high minus high d low, so high derivative of low, all over low low. Okay, so that's just a cutesy little acronym to help you remember it. So quotient rule. Quotients are easier to recognize. So we do bottom. I always say it this way: bottom derivative of the top minus the top derivative of the bottom, all over the bottom squared. Again, the order of g and f prime doesn't matter though. So we do the bottom derivative of the top. Derivative of x squared is 2x. Derivative of x is 1. Derivative of negative 2 is 0. Minus the top. Derivative of the bottom. All over the bottom squared. Now you could go crazy simplifying this if you wanted to. You could FOIL this all out, combine like terms, simplify to your heart's content. Do you need to? No. If it was multiple choice on the AP exam, yes, you would need to. Do we need to eventually? Yes, because we're going to use this to find some stuff. So if you want to practice simplifying, you can, but I don't know that it's necessary right now. You're going to try this one. It's just kind of a basic quotient rule. So then we'll do a couple more. Find the equation of the tangent line, one with a g of x in there, and then I just at the very end want to talk to you about how you can avoid using the quotient rule in certain cases. So we want to find the equation of the tangent line to this function at this point. So you're given the entire point. The main thing that we need to do then is find the derivative, because the slope of the tangent line is the derivative. So we take the derivative. We have to use quotient rule. Bottom derivative of the top, derivative of e to the x is e to the x, minus the top, or, oh, for goodness sakes, bottom derivative of the top minus the top derivative of the bottom. There we go. All over the bottom squared. All right, so now we need to figure out what this is. Remember, this is the slope of our tangent line, but we don't want this. We want a number. So we need to plug 1 into it. So this is going to be 1 plus 1. 1 squared is 1. E to the first minus e to the first times 2. 2 times 1 is 2. All over 1 plus 1 squared. So this is 2e to the first minus 2e to the first. Our numerator is 0, so the whole thing is going to be 0. So our slope of our tangent line is horizontal. So then if we want to write the equation y minus our y coordinate equals 0 times x minus our x coordinate, or if you are really smart, you already know that it's y equals 1/2 e. It's just y equals the y coordinate because it's a horizontal line. Okay, last one, and then I want to talk about, because most people don't like the quotient rule, how you can avoid it in certain cases. So this is, again, kind of a conceptual problem. You don't know what g is, so it's not like straightforward, just take the derivative. Derivative of f is going to be bottom, derivative of the top, we know how to do that one easy, minus the top, derivative of the bottom, derivative of g, we don't know what g is, so we're just going to write g prime. All right, always acceptable if you don't know what else to do. Just write that. And then all over g of x squared. All right, and we want to find, oh, I forgot to say, find f prime of 4. Well, we can't just find f prime of 4. We have to find f prime first. So then we plug 4 in. So this is g of 4 times 8 minus, let's see, 4 squared is 16 minus 1 is 15 times g prime of 4. Oh, we could just plug that in. I could have skipped some steps. All over g of 4 squared. All right, so now what's g of 4? It's 2. So 2 times 8 minus 15 times 3 all over 2 squared. So that is 16 minus 45 all over 4. Oh, I'm so bad at subtracting. 45 minus 16. That's going to be 29. So 29 fourths. All right. How to, hopefully I did that right. How to avoid quotient rule. If you have a single term, a monomial, that's what I want to say. If you have a monomial in the denominator, you can avoid quotient rule, especially if your monomial either doesn't have a coefficient or doesn't have an x. Like if you have something like x squared minus x plus 1 over x. All right, we did something like this back in section 3. You can simplify that. You can break that up so that you don't need to use quotient rule. All right, and then you can take the derivative kind of the traditional way. All right, so this, you can avoid quotient rule by doing something like this and simplifying it. If you have just an x in the denominator, or just an x squared, or just any power of x, you can do that with. If your denominator is a constant, all right, then you really don't do quotient rule. If your denominator is a constant, please, I'm begging you, don't do quotient rule, because the derivative of your denominator is going to be 0. Just write it as 1/5, pull the 5 out and write it as 1/5 times all that. And then when you take the derivative of that, the 1/5 just stays. So please don't use quotient rule for something like this. And I would even probably not use quotient rule for something like that. Now, if you have a coefficient and an x, like if you had a 5x in the denominator, you could pull the 5 out as a 1/5 and then do this. So that would make this 1/5 times all of that. So that is also a possibility if you wanted to do that, okay? But please, especially if it's just a constant in the denominator, don't do quotient rule. It would break my heart.